So of course my hair isn't cooperating. All right, so today what we're working on is solving equations. This is stuff that you guys have done in Algebra 1, but it's been a couple years since you took Algebra 1, so we definitely want to refresh it, right? You probably did a little of it in geometry as well. Um, the basic steps, the steps for solving equations would be distribute. If you can distribute something, do it, right? Number 2 would be simplify each side. When we say each side, we're talking about each side of the equal sign, right? How do you do that? Combine like terms. Reduce fractions where you can. All sorts of ways to simplify each side. Number 3 would be move your variables to one side. I say move the variable you're solving for, because sometimes you'll have more than one. So and number 4 would be to solve using inverse operations. Inverse operations, well, let's talk about operations in general. Operations are just what's being done to something. So more often than not, our operations are addition, subtraction, multiplication, division, right? Those are our main mathematical operations. Inverse operations would be whatever the opposite is. So if I've got something being added, if I want to move it, I would subtract, right? If I have something being multiplied, if I wanted to move it, I would divide. I would be using those opposite operations to solve for variables. Up here, let's start with a simple-ish one, right? If I have, say, 6 times x plus 5 equals 2, and I want to solve this equation, what I'm asking for is to set that variable equal to something. I want to know what x is. What is x going to be that makes this true? And that is how we solve equations, right? How do I make this statement true? If we go by our little rules that we have over here, the first thing would be to distribute. And the only time you need to distribute, you'll know because there will be parentheses, right? If you need to distribute. If I have something on the outside of these parentheses attached to the outside, I am going to want to multiply it through. 6 times x equals 6x. 6 times 5 equals 30. And then we're just going to leave that 2 alone because it's on the other side. So we've done our distribution. According to our steps, our next step would be to simplify each side, combine like terms, reduce fractions. But if you look at each side of this, it's as simplified as it can possibly be. I can't add 6x or 30 to anything else on this side of the equation. It is as simplified as we can make it. The only thing more simple than that is this 2 on the other side, right? There's literally nothing to do with that. It's just a 2. So number 2 is we just skip on by it, right? There's nothing we can do there. So now it says move the variable to one side. We want all the variables, all the x's or y's or b's or c's, we want them on one side, and then we want to start working our numbers all the way over to the other side, right? So in this case, our variable is x, right? A variable is just a holding pattern for a number that we don't necessarily know, right? And we're trying to find out what that has to be to make this a true statement. And the way we're doing that is we're going to get x by itself. We're going to set it equal to something. Since the variable is already on one side, we get to move to solve using inverse operations. Solving just means getting the variable by itself on one side of the equal sign. We want to know what the variable equals. In this case, our variable is x. And so we're going to start undoing everything that's being done to that variable. And if you look at it, this right here is 30 being added to it, right? This right here is 6 being multiplied to it. And so to undo those things, we're going to do the opposite of them. And when we're solving for an equation, you guys know about PEMDAS. We talked about it last week, right? If you remember, M and D are equal, A and S are equal, right? It's not multiply before divide or add before subtract, they're equal. When we're undoing something, though, we're going to use backwards PEMDAS, right? So if I'm looking at what's being done to x, I'm not going to deal with this multiplication first. I'm going to deal with the addition first, right? And I see that 30 is being added to it. So to get rid of it, I'm going to subtract 30. But I can't do it to just one side, or I mess with the equality. I change the value of the equation. So anytime you do anything to something with an equal sign, you have to do it to both sides. And you can literally do almost anything you want to any equation as long as you do it to both sides of that equation, both sides of that equal sign. So we have 30 being added, so we're subtracting 30. And that is going to give me 6x. These cancel, right? 30 minus 30. 2 minus 30 is negative 28. So now the only thing left being done to that x is that it's being multiplied by 6, right? When it's right up next against that x, it means multiplication. And so I would do the opposite of multiplication, which is division. So I'm going to divide both sides by 6. And I know I might be over-explaining things right now, and you're like, I totally get this already, Miss Way, you don't have to break it down so much. But I don't know who gets what, so I want to make sure that I say everything, because it's been a while since you guys have done math. Now, I have negative 28 over 6. Can I leave a fraction as negative 28 over 6? I mean, and not make me as a math teacher cry? Well, this one I don't think will divide to an actual number, because 6 doesn't go into 28 evenly, but I can reduce that fraction because I have an even number on top of an even number. And I'm not a super stickler for reducing fractions, but when it comes to having an even number on top of an even number, it's sort of a pet peeve of mine. You can at least divide each of them by 2 and see what you get. 28 divided by 2 is 14. 6 divided by 2 is 3. And that is a legit solution. All right. It is my biggest pet peeve when you leave an even number over an even number and don't reduce it. Like, if you get something crazy and you don't reduce it, I totally get it. But if they're both even, at least divide them by 2 until they're not. Now that was fairly simple. We're going to move into some more complex stuff. What if I have, I didn't like, it didn't make a little circle for me. 3 times 5 minus 3x over negative 4 equals negative 15. Now it says the first thing that I need to do is distribute, and we can do that pretty easily, right? We've got some parentheses. We can distribute that through fairly right off the bat, right? I can go 3 times 5 equals 15. 3 times negative 3x equals negative 9x over negative 4 equals negative 15. So for a million imaginary points, how do I get rid of that negative 4? Right? I got to start pulling stuff off of this x, but right now I got that negative 4 underneath. How do I get rid of that? Nobody's willing to work for imaginary points. Yeah, we're dividing by negative 4, so definitely multiply, right? What would I multiply by? No, I can see why you would think that. But the whole idea is to clear out that negative 4, right? And if you think about the way we do that is if I have anything over itself, it becomes 1, right? So if I have, think of this in terms of it's 1 over negative 4, right? If I want to turn that into negative 4 over negative 4, I would have to multiply it times negative 4, right? And that's what would clear it out. So if I have something in the denominator and I want to clear that denominator, I want to multiply the whole thing times negative 4. I'm going to do it in a different color so that you can see. Plus, I'm going to fix it so it doesn't look like negative 9. I'm going to multiply this whole thing by negative 4 because that's going to allow me to cancel this. The only thing is, I also have to multiply this whole thing by negative 4, right? Because I can't do something to one side of an equation that I don't do to the other side of the equation. It is the number one law of things being equal, right? I can do anything I want as long as I do it to both sides. So what happened when I do that is this gives me negative 4 over negative 4, which is just 1, which just cancels out. And I'm left with 15 minus 9x equals negative 15 times negative 4, which is positive 60. And so now we're looking at something we know how to work with a little bit better. Here is a part where people screw up all the time, right? Now we have to start getting that x all by itself, right? We got rid of the negative 4 that was being divided, but now we have this 15 that's being added to it, and this negative 9 that's being multiplied to it, and I need to start taking those off. And like I said, when we're dealing with undoing something, we're using backwards PEMDAS, so we wouldn't deal with the multiplication first. We'd start with this 15 that's being added to it. So I am going to subtract 15. That is an ugly 5. That's so ugly, like I can't even leave it like that. I have to erase it. I don't even care that I messed up my 60. That's so much better. 15 minus 15 is 0, so we're just going to be left with minus 9x equals 45. And now the only thing we have left that's happening to that x is the negative 9 is being multiplied to it, right? And so I have to do the opposite of multiplication to get rid of it, which is division, right? This is being multiplied by negative 9. To get rid of it, all I have to do is divide by negative 9. But I have to do it on both sides because it's the law of math. 45 divided by negative 9 is just negative 5. This one's nice because we get a nice clean answer, no fractions. It even made a nice box for me, right? Are we done with this problem? Heck yeah, we are. We know we're done because there's a box around it, right? So crazy little bit, but not too bad, right? We can work with this. What happens if we have a variable on both sides of the equal sign? I don't know. Let's see. It's like talking to myself right now. I got a couple faces in there though, so it's kind of nice. But let's do it kind of simple though. If I have 10, I don't know, let's call it y. 10y minus 7 equals 21 minus 6y. That's 21 minus 6y. It's not some weird line. I mean, it looks like a weird line, but it's supposed to be the number 1. So I have 10y minus 7 equals 21 minus 6y. The first thing I have to do is I have to look and see if there's anything to distribute, but we don't see any parentheses, so clearly nothing to distribute, right? The next part said to simplify, right? Both sides of the equation, but there's nothing to simplify. I can't combine 10y minus 7 any more than it's already combined, and I can't combine 21 minus 6y on that side any more than it's combined. They don't go together, right? So my next step is to move all the variables to one side. I am going to move them all to the left side. I always like to have my variables on the left side because ultimately what I'm trying to do is set them equal to something, and I like to read them as y equals or x equals. So I just always move them to the left. Does it matter? No. But I'm going to start by moving this 6y over to this side, and it's a minus 6y, so I'm going to do it by adding 6y. 6y plus 10y is 16y minus 7 equals 21. Minus 6y plus 6y is just 0, so that was the whole point, right? Was to get it to the other side. Now I can start undoing all the stuff that's being done to that y. And the first thing that I would start with is what's being added or subtracted to it. So in this case, we are going to add 7 to both sides. And I would get 16y equals 28. Didn't we just have 28? 28, just something before. Now, the only thing left being done to our letter y is 16 is being multiplied to it. Does anyone know how to get that 16 off that's being multiplied to it? I'm not even going to offer a million imaginary points because you guys don't seem to like the imaginary points. You want real ones. Divide. What do I divide by? You're all right. It is divide. Exactly. How did the 2 turn into a 28? There's no 2. It was a 21. That's a good question because it's an ugly 1. I could tell why you might think that. So we are going to divide by 16. When I do that, I am left with y equals. Well, I'm left with y equals 28 over 16. Can I reduce that fraction? Right, they're both divisible by 2. If I divide this by 2, I get 14. If I divide this by 2, I get 8. Well, look at that. It's still divisible by 2. My hand is... That is the worst equal sign ever. That is equals 7/4. Thanks, Jameson. Does that make some sense? You guys kind of get a feel for that? I'm going to show you one other thing that I need you to know how to do. And then if you want, I can do some more complicated problems. But I added some proportion problems to your homework. So I want to make sure you remember how to do proportions. It's still just solving for a variable, right? It's just a fraction set equal to a fraction. So when you're dealing with proportions, if I have, say, 5 over 3 equals 2 over x plus 4, does anyone remember how to solve something like this? How you can rewrite it to solve it? You don't have to remember, but if you do, that would be cool. Yes, Alyssa, exactly. You just cross multiply. So I would take the 5 and I would multiply it times x plus 4. So I'd have 5 times x plus 4. Make sure when you do this that you put this quantity in the parentheses so that you know that you're multiplying the 5 times the whole thing, right? Not just the x. Equals 3 times 2. So then we would go ahead and distribute, and we just start solving like we were the other problems. So I would go 5 times x gives me 5x. 5 times 4 equals 20. 3 times 2 equals 6. And now we can just start undoing the things being done to x and get x by itself, right? First step would be subtract 20 from both sides so that we have 5x equals negative 14. Then we still have the 5 being multiplied to it. So we would divide by 5, right? The opposite of multiplication is division. And we would wind up with x equals negative 14 over 5. So when you have a fraction equal to a fraction, all you have to do is cross multiply. And that's how we handle proportion problems. Do you want to see anything more difficult? Let me look at your homework really quick. The first couple I made really simple. The next two are proportions. I used simple proportions. I was going to do some crazy fraction problems, but I didn't include any crazy fraction problems in your homework at all. So, so that's really all we have to do. I can do some more complex problems if you would like, some more complex examples. Homework will be posted right after this class. I'll get it posted.